Do you spend hours building a robotics project and it still look like this? The wires are loose, the connections break, and honestly you are scared to touch it in case it stops working. I know the struggle. To make things stay put, maybe you grab soldering iron. It's hot, it's dangerous, and once you solder a wire, it is permanent. You cannot change your mind. Or perhaps you use duct tape. It gets sticky, it looks messy, and it's a real pain when you need to fix a mistake. These tools are great for finishing products, but when you are learning or experimenting, they turn your project into a real mess. But what if there was a way to connect components without glue, without tape, and without soldering iron? Allow me to introduce the breadboard. And in this video, we are going to see what a breadboard is. So let's get started.
Edusoft Robotics. Comprehensive STEM and robotics solution.
This little plastic board is the absolute best friend of every robotics student and engineer. It transforms your messy junk project into a clean professional circuit. So, what is it? Basically, a breadboard is a construction base for prototyping. Prototyping just means testing your ideas to see if it works. It is full of tiny holes. Underneath these holes are hidden metal clips that grab onto your wires. How do we know which hole connects to which? To understand this, let's imagine a breadboard as a miniature city. Look at the long strips running down the far left and right sides. These are usually marked with red and blue lines. Think of these as the main power cables running down the street, supplying electricity to the whole city. Now, look at the middle. You see these numbered rows? Row 1, row 2, row 3, and so on. Imagine every row is a small housing society or a block. Each block has exactly 5 houses. House A, B, C, D, and E. All of these 5 houses in one block are connected neighbors. If you plug a wire in house A and another wire in house B of the same row, they are electrically connected. It's like neighbors are holding hands inside the walls. However, notice the gap in the very center. This ribbon separates the city into east and west. Row 1 on the left side is not connected to the row 1 on the right side. They are different neighborhoods. This is super important when we start using computer chips later on. Now, just like the cities vary in size, so do breadboards. We have mini breadboard, perfect for tiny robots that need to fit in small spaces. The half size. This is the standard one you will use for most school projects. And the full size, for which you are building something massive. But remember, the rule for the 5 connected house is exactly the same for all of them. Let's now create a simple circuit using a breadboard. First of all, we will take a breadboard and place it on a table. Connect the positive terminal of the battery to the positive power rail and negative terminal to the negative power rail of the breadboard. Place an LED on the breadboard. The legs of the LED should be placed on the different rows as shown here. Connect one end of the resistor to the positive rail of the breadboard and one end to the anode, which is the positive terminal of the LED. Now take a jumper wire. Place one end of it to the negative rail of the breadboard and other end to the cathode, which is the negative terminal of the LED, as shown here. And boom, a clean working circuit. And the best part, If I made a mistake, I just pull the wire out and move it. No mess, no waste. So the next time you have a brilliant robotics idea, don't let it become a chunk pile. Use a breadboard, respects your time, it keeps your work tidy, and it makes learning electronics a breeze. If this video helped you understand how it works, please give this video a thumbs up and subscribe for more robotics tutorial. Go build something awesome and I'll see you in the next video. Thank you.